Pretend this is a view from the International Space Station that has been visited by astronauts from countries around the world over the past 25 years. What do you notice? There's a seemingly infinite supply of water, both on the ground, in rivers, streams, and oceans, and in the sky as clouds. But very different reality exists for the astronauts when they're living, researching, and surviving inside the International Space Station. Here, water is in a much shorter supply. But astronauts are smart. We all know this. They've come up with a way to combat this problem. Did you know that 98% of the water created in the space station is recycled, even urine and sweat? Once recycled, it's then used as drinking water once again. They have learned not to waste their valuable water. Today, I'm going to take you on a bit of a time travel between the past, the present, and the future, as I dive into how we traditionally looked at our own wastewater and how, if we open our minds, we have the opportunity to create a better future. I want you to close your eyes and listen for a moment. This is a familiar sound. Can you guess what it is? It's the sound of rain falling. Now close your eyes again and listen. How about this next sound? This sound, or lack thereof really, may be familiar to those of you in the room today in early February, or other Canadians and others in cold climates. It's the sound of snow falling. A bit too much of it for my liking this year, but being a typical Canadian, we like to complain about weather, don't we? Water is all around us and necessary for life, but how we utilize this valuable resource as humans? Let me bring you back in time when you were in grade 3 or grade 4, which may have been longer ago for some of us, myself included, than others, and maybe some of you are actually in grade 3 or 4 right now. Does this image look familiar to you? Don't be afraid. You can put your pens, pencils, and laptops away. Although I am a professor, I'm not going to test you on this. If this image doesn't ring a bell, let me jog your memory a bit. This is a water cycle. This cycle includes precipitation we just did and did not here. This type of image hasn't really changed over time, but there's something missing, a piece of the puzzle that plays an important role, but has been left out of our grade 3 and grade 4 curriculum. Does anybody know what's missing? There, I heard people. Humankind, people. You and me, right? Throughout time, we've been moving water around by various means as people. Like all animals, we need water to live. This especially became important when we start to build cities that were thirsty for water. Let's go back in time to see how early engineers provided water to cities around the world. This image is an aqueduct similar to those found and built in ancient Rome around 300 BC. The ingenuity of people always amazes me, as these aqueducts were able to move vast quantities of water from remote areas into cities using only gravity. Our current water and wastewater infrastructure uses gravity too, but we also add in pipes, pumps, electricity, and other infrastructure to bring clean, safe drinking water to our houses. But more importantly for this talk today, where does all the used water, that is now dirty wastewater, end up after we're done using it? What happens to it? Right? One destination is our toilets. They even had toilets in ancient Rome, where these facilities were conveniently located right next to streets where you could multitask and talk with your friends and neighbors while using the toilet. To build on the ingenuity of ancient people, now that we figured out how to bring water into the city, we need to figure out how to bring it back out of the city. Thus, we had sewer infrastructure was introduced. Let's fast forward back to present day. Since the Romans, we've developed infrastructure to move municipal wastewater, a nicer way of saying sewage, out of our buildings. Your home is likely connected to the citywide sewer system that takes away all your used water so you don't have to deal with it. But I do. I know, lucky me. Unlike the ancient Roman sewers, our wastewater today includes not only toilet flushing, but also water coming from bathing in showers and tubs, from sinks, washing machines, and dishwashers. In fact, despite the stigma around wastewater, most of what we call wastewater doesn't actually come from toilet flushing at all. Did you know that we as Canadians use 300 liters of water per day each? I know, that's a lot of water. Of these 300 liters, only about 25 or 30% of them is actually used for toilet flushing. Most of it is actually used when we're taking a shower in the tub. So where does this wastewater go after we use it? This is an example of one treatment process within a municipal wastewater treatment plant. In these plants, water is allowed to settle out, it's injected with chemicals, munched away by friendly microorganisms, and then typically treated using UV disinfection and or chlorination. This rigorous process safely allows the water to be returned back into the environment. In fact, this water is actually cleaner than the water in the environment for the most part. But doesn't this seem wasteful to you? We put all this effort and money into creating clean drinking water, collecting the wastewater, treating it, and then we just put it back into the streams, lakes, and groundwater. In fact, we spend billions of dollars a year in Canada alone just to maintain our water and wastewater infrastructure. As climate change and water scarcity become more pronounced worldwide, we are thinking of our wastewater treatment plants more as a resource and less as a burden. I believe now is the time for wastewater reuse. After all, if water reuse is good enough for the astronauts up in space, why not for the rest of us here down on Earth? So I'm sure you're wondering, Carrie, why do you have the fish implant on stage with you today? Fortunately, the fish is alive, sitting here overnight. I invite you to come with me into the future. This is a typical scene in a household of the future where the fish is swimming happily in clean water. Now pretend this water originates from wastewater reuse, which is just as safe and clean as our regular tap water today. This plant that I've managed to have alive in my office for the last couple of years can be fed the same water. But even bigger picture, imagine having wastewater reused for irrigation waters on a larger scale, or for fish farming, or for industrial water use, or even for drinking water. I'm an environmental engineer at the University of Saskatchewan. My research team, as well as many others throughout Canada and worldwide, are working on cutting-edge wastewater reuse technologies that are both safe and cost-effective for creating a wide range of water for human use. I want to help to create a water cycle 2.0, if you will. This new human-centric water cycle will mimic the water cycle I just showed you, which is basically a big circle. We take water from the environment, make it safe for human use, capture the wastewater and treat it, and then use it again for human reuse rather than putting it back into the environment. As you may imagine, there are many steps necessary in wastewater reuse process, which, if you attended one of my classes, you could learn all about. But today I'm just going to show you one example of a treatment process. This is part of a membrane treatment process being developed using state-of-the-art technologies. Think of it as a water filter with very small openings in it. It can remove contamination from water, helping to create fresh water for reuse applications. So the water leaving the wastewater treatment plant is clean enough for the environment, meaning it's free of anything that would harm the trees, plants, and animals. But can we make it safe for human consumption? I say yes, we can. We have the technology to make this happen. That's not the problem. The biggest thing standing in our way of actually doing this is public perception, the ick factor. Would you be willing to drink water that came from a wastewater treatment plant? Because I would. The water I'm drinking here today actually started its life as wastewater captured here in Saskatoon. It was treated by my research team, who hopefully did a good job. I see them out there. They make it safe enough for me to drink here on stage today. Now, the message I want to leave you with is that in order to find solutions to complex problems like climate change, water scarcity, and wastewater reuse, we can't be doing the same things we've always done. We have to be willing to think differently. We should be looking at the new ways to reuse water that haven't been thought about before. We have to open our minds to think beyond that ick factor. So let me ask you, will you come join me and embrace wastewater reuse today? Thank you.